Hi everyone, and welcome back to this channel. In today's video, we will be exploring the concept of ionic radius, which is a crucial idea in chemistry. As your regular host, I'll be guiding you through this topic, Introduction to Ionic Radius. In the last video, I explained the concept of atomic size of elements in the periodic table. I explained that atomic sizes decreases across the period from left to right, while the atomic size of elements increases down the group. This is due to the fact that down the group, extra shells or energy levels are being added to the atom of every element. But across the period, from left to right in the periodic table, there is an increase in atomic number. Therefore, there is an increase in the number of protons, and simultaneously, there is an increase in the number of electrons. The force of attraction between the protons and the electrons causes the decrease in the atomic size. As you know, that unlike charges attract. This attraction makes the atomic sizes across the period decrease from left to right in the periodic table. But today, considering a neutral atom, for instance, sodium atom, here in the nucleus of this atom, there are protons and neutrons which are clustered together in the center, forming the nucleus. Don't forget that the mass number, which is the weight of an atom, is the addition of the protons and the number of neutrons. The electrons are negatively charged, fast-moving particles which are orbiting around the nucleus of an atom, and electrons must be transferred before an ion is formed. Electron must be gained or lost before an ion is formed. In this slide, you will agree with me that sodium has two electrons in the atom in the innermost shell, and in the middle shell, 8 electrons. The outermost shell having 1 electron. When this sodium atom loses 1 electron, which is an occupant of the outermost shell, it becomes an ion with a stable electronic configuration, which is similar to the electronic configuration of noble gases. Eventually, the ion formed has a smaller size compared to the atom size. This same trend is observed in elements from group 1 to group 2 and to group 3 of the periodic table. Sodium atom loses 1 electron to become a positively charged ion known as cation. Magnesium atom loses 2 electrons to become a positively charged ion with a loss of 2 electrons. And this applies to aluminum in group 3. Therefore, the periodic trend is there is a decrease in the ion size from left to right in the periodic table. Incidentally, the group 4 elements peaks in ionic size, but when we get to the group 5 elements, down to group 8 elements, there is an observable decrease in ionic size across the period. Don't forget that chlorine is a nonmetal with electronic configuration of 2, 8, 7. Chlorine atom attains a stable electronic configuration of a noble gas by the gain of one electron to obey the octet rule. As a matter of fact, the size of this ion is observably bigger than the size of the atom. This is due to the fact that extra electron in the shells brings about a repulsion among the electrons. Apparently, there is a trend in the size of ions. The positive ions have a decreased size from left to right in the periodic table. The same applies to the negative ions, which also decrease in ionic size from left to right in the periodic table. There's a general increase in ionic size of elements than the group. This is due to increase in the nuclear charge and the general sizes of ion than the group. Understanding ionic radius is essential in chemistry because it helps us predict the properties of ionic compounds. Properties like melting and boiling points, electrical and thermal conductivity, ionization energies, and electron affinities, electronegativities, and other properties that are not mentioned in this video. However, a study of the variation of ionic radii with atomic number shows that the ionic radii of positive ions are smaller than the corresponding atomic radii. Secondly, the ionic radii of negative ions are greater than the corresponding atomic radii. In a group of ions having the same number of electrons, the ionic radius decreases as the atomic number increases. That is to say, that as the nuclear charge increases, the electron cloud contracts as it is pulled more effectively towards the nucleus by the increasing positive charge. That's the wrap on ionic radius. I hope that this video helped you to grasp this essential concept in chemistry. Thanks for watching, and don't forget to subscribe for more educational content. If you have any questions or topics you would like us to cover, please comment below. See you in the next video.